Hi, okay, so the previous two videos on sets have shown you how sets can be used to find the unique words in the complete works of Shakespeare, if you like, the vocabulary of Shakespeare, in a hugely faster way than would be possible if you used just lists. And there's one slide in the lecture notes called How It Works, hashing, and at this point I'm going to defer to my last year's self, change clothes, go back 1 year and give you the same story as they got last year. The last thing I want to do in this video is explain how this works, which it seems very impressive that I can have a set of 1 million odd strings and then in some very small amount of time I can ask if a single word is in that set. So it works by means of something called a hash function. So a hash function is something built into Python. So I'm going to demonstrate it in a slightly novel way. I'm going to say, what's the hash of goat? So hash is a function like len, it's a global function. And when I run it, it tells me there's the hash of goat, which is a long and apparently useless string. What's the hash of a horse? It's a huge negative number. What's the hash of a pig? I think you're probably getting the idea that a hash of anything is some random number, apparently a random number, but it's always the same. If I repeat hash of pig every time, I always get the same answer. So it's not random, it's based on or computed from the parameter. But apart from that, it looks random. So if I ask, well, what's the hash of pig gig with an extra G, you might think, well, it'll be kind of similar, but no, it's miles away, no relationship at all. Any small change in the string I give it gives me an apparently totally different random number. And the way we use that to create a hash table, which is what the set is underneath, there's this fancy word hash table here, I'll now demonstrate. So I'm going to create a table. Now I'm going to use list comprehensions, which you're not necessarily meant to understand at this point. So if you don't know about list comprehensions, you can kind of skip this. I'm going to say it's the empty string for I in range 100. Whoops, or I in range 100. So now if I look at my table, it's 100 empty strings. It's a list. These things are good to know about. They are covered in one slide in the lecture notes under the lists. You may wish to go back and look at it. We don't examine you on that. It's not officially part of the curriculum, but it's really, really good to know about. So if you feel comfortable with the rest of the course, go look at that. So now let me look at my hash of a goat here. It was that number. That number is a very large number, but I'm going to reduce that using the modulo operator, that's that percent thingy, into the range 0 to 100. Now, many of you may not remember too much about modulos, but let me just show, it's very easy. Hash of goat mod 100. And it comes out to 79. That's essentially the remainder after dividing by 100, at least in this case because it's a positive number. If I ask for hash of a pig, I get a different place, 71. If I do hash of a, what else do I have to put in here, a horse, and I get 44. So notice what I can do now. I can do something like the table at location 79, which is the hash of a goat, will be equal to goat. I can do the same with a pig, and to make it clearer what I'm doing, I'm setting the table at the location obtained by hashing the string. Oops, I didn't mean to do that. The location obtained by hashing the string. I'll do pig this time. And I'll set it to the actual string pig. What did I do wrong? List assignment out of range. Oh, I forgot to reduce it modulo 100. Dumbo mod 100 is pig. So now if I look at my table, remember the hash of pig was some ridiculously large number. Reduced mod 100, it was 71. So I now have in my table the pig and the goat. And I can put in the horse as well by using the same model again. So I'll set the hash table at the location obtained by hashing a horse and reducing it modulo 100 to the string horse. Looking again, I've got those goat, pig and horse, and they're in 3 sort of random places in my table. Now, if I want to know if pig is in the table, it's now very easy, and it's relatively cheap. I just ask, what's the value at the hash of pig mod 100? Just see what I get. I get pig. Woohoo! Pig is in the table. What if I ask about a cow? What's at the location hashed cow mod 100? Empty. No cow there. So that, in a fairly largish nutshell, is how hashing works to give you very, very fast access. It doesn't matter how many items are in the table. This table could be 1 million items. I only ever look at one of them to see if the animal is there. Well, actually, some of you may have noticed there's a potential problem. If these are sort of random numbers, what if another animal, a Saskatchewan millipede lands up on top of a pig? What do? Well, in that case, I have to put our Saskatchewan millipede somewhere else in the table, and that's called rehashing, and you'll learn about that in COSC 122. This was a quick look, and please do 122. It's a great course, and it'll teach you all about data structures and how we do a lot of clever computer science stuff. So that's how hashing works, and sets use hashing, and you can only put something in a set if it's hashable. If I try what's the hash of a point P, I've got a point P already, haven't I? Let's hash it. That works fine, but I have a list somewhere. I can't remember what it was called. Was it numbers? No, numbers is a set. Let's call it data. Oh, it was already called data. Okay, what's the hash of data? Unhashable type. So the hash function, you can't do it on data. And maybe you can see why this is a problem, because if I hashed data and then I put another item in the list, now I've got a problem, because the item is not the same item. I've modified it. Does its hash change? If its hash does change, then the whole model breaks down. If its hash doesn't change, then how do I distinguish one list from another? So that's why you can't put mutable types into a set. Okay, well, as brief asides go, that was a somewhat long aside. So that's the end of the explanation of how hashing works. More details in COSC 122. See you in the next video. Bye.